Welcome to the Walton Pi. Today I'm going to go through a problem that might show up on a calculus test involving the mean value theorem. So for this problem, we're going to say that we're going to find the c in the interval -3 to 2, which satisfies the mean value theorem for the function f of x equals 3x cubed minus 4x plus 7. Okay, so before we get started, if you haven't already, please consider subscribing. It really helps me out to be able to keep making these videos. Okay, so how would we approach this problem? Well, first we're going to need to remember, what does the mean value theorem say? So the mean value theorem, I'm going to abbreviate it as the MVT. That says that if we have a function f which is continuous on an interval from a to b, which is a closed interval, and is differentiable on the open interval, if both of those things are true, then there is a c in the open interval from a to b where f prime at c is equal to f of b minus f of a divided by b minus a. Alright, so that formula, that's ambiguous or not necessarily immediately clear what it means, but if we look at a picture, so maybe this is our function f, this is our function f. Here is our value f of a, here is our value f of b. If we figure out what does f of b minus f of a divided by b minus a, what does that mean? Well, that is finding the slope connecting the line between them. So that's equal to that f of b minus f of a all over b minus a. Alright, so what we're really doing is we're saying, find the place on the function where the slope of the tangent line equal to the slope of the line segment connecting the 2 points. So that's what we're really trying to do. We're trying to find where is the derivative equal to the average slope. Okay? So if we have all of that together, and we're trying to figure that out for this particular problem, that means we are trying to find the place where the derivative is equal to the slope between those 2 points. So let's just calculate what those different things are. So in this case, what we have is we have f of b, so that's our f of 2. We need our f of minus 3, and we're also going to need to know what's our derivative function. Well, let's start with f of 2. So if we just plug in 2 and see what we get, this is 3 times 2 cubed minus 4 times 2 plus 7. So that is 3 times 8, so that's a 24 minus 8 plus 7. So that's equal to 23. f of negative 3, that's 3 times negative 3 cubed minus 4 times negative 3 plus 7. So that is 3 times negative 27, so that's a negative 81, plus 12 plus 7. So let's see, so that's negative 81 plus 19. So let's see, 81 minus 19, that's going to be, no, 6. Yes, so that's a negative 62. And then f prime of x, that's going to be a 9x squared minus 4. Okay, so now that we have all of this stuff together, let's go through and piece all of this together to say, what does the mean value theorem tell us? So the mean value theorem says that there is a place c in the interval from negative 3 to 2 where f prime of c is equal to f of b, so 23, here let's actually write that all the way out, f of 2 minus f of negative 3 all over 2 minus negative 3. So that's going to be equal to 23 minus negative 62 all over 5. So we are looking for where f prime of 3 is equal to 23 plus 62, so that's 85. Of c is equal to 17. Now what is f prime of c? Well, f prime of c, that's just plugging in c into our f prime equation. So that's a 9c squared minus 4. So what we're looking at is we're solving for where is 9c squared equal to 21. So if we keep going through and solving this, that means we are looking for where c squared is equal to 7/3. So c is going to be one or the other of the square root of 7/3. So we need to know which one of these is between -3 and 2, and it turns out that both of these are. So this one we actually have two different solutions. We have c is plus or minus the square root of 7/3. And both of these actually work. Now, quick question. Does that mean that the mean value theorem was wrong? Because the mean value theorem just says that there is a c. Well, it turns out that the mean value theorem just says that there's at least one. It doesn't tell us how many there are or if there's going to be more than one. It just says there is at least one and then that it is guaranteed to exist. So just because we found more than one does not contradict the mean value theorem. Similar to the picture that we drew earlier, if we look here at this picture, there's two different spots where the slope was actually the same as the slope connecting them, and so that is a perfectly fine result for the mean value theorem. The mean value theorem just says there is at least one solution. So I hope this video was helpful in understanding the mean value theorem a little bit more. I hope you have a great rest of your day, and good luck with all of your math.